This video is intended for demonstration purposes only and should not be followed as an exact installation procedural process. Users should refer to the official manuals for the correct installation procedure. This equipment must be installed by professional technicians who are familiar with the equipment and the design of the photovoltaic system. This instructional video will take you through the process of replacing an arc fault device for the PVI 5000 and 6000 series of inverters. If you're working on a PVI 3.0, 3.6, 3.8, or 4.2, please refer to a different video. Remember that this video provides instructions to install or upgrade the arc fault device kit and only applies to inverters which have an arc fault detection capability. The arc fault enabled inverters can be identified by the label on the right side of the inverter. There are two main label types as shown. This procedure involves working in the inverter switch box where both hazardous DC and AC voltages can be present. All work must follow the described documentation and comply with all prevailing safety and electrical codes and regulations for high voltages. Appropriate personal protective equipment, or PPE, must be worn during this procedure. All operations on the equipment must be performed with suitably insulated tools and instruments. Before you start your installation, review the entire video and/or the work instructions to ensure the correct installation of the arc fault kit. The following equipment and parts are required to successfully complete this procedure: flathead and Phillips head torquing screwdrivers, Torx T20 driver, cable ties, proper personal protective equipment, the arc fault detection kit, which contains the following items: 4 10-gauge wires, one red, one black, one blue, and one brown. Each is identified for the positive and negative DC inputs, arc fault detector, and ECO label to be placed on the outside of the inverter upon completion of the arc fault device replacement. We are now ready to begin installing the arc fault kit. The first step is to turn off all hazardous voltages to the inverter. Turn off the AC grid connection to the inverter. This can be done by opening the corresponding backfeeding breaker. Turn off the DC disconnect switch at the inverter. Disconnect the DC array by opening the string fusing or disconnecting the DC MC4 connectors for each string. Remove the two inverter covers using the Torx T20 wrench. Verify there are no frayed wires at the connection points. If the inverter has a DC input from only one string instead of two or more strings, the unit should be set to parallel mode with 2 sets of paralleling jumpers installed. One set is installed on the switch box and the other set is terminated in the upper compartment at the DC input board. Do not remove these jumpers, even though they are not shown in subsequent steps in this video. The next step is to remove the existing arc fault detector. To remove the arc fault detector, we are going to start by disconnecting the 4 DC wires from the top of the DC terminal block and the bottom of the disconnect switch. In this example, the wires are red, black, blue, and brown, but they can be different colors in the inverter that you are upgrading. Disconnect the black communication connector from the top of the arc fault detector. Gently move the communication cable out of the way. Next, remove the arc fault detector from the DIN rail. Insert a flathead screwdriver into the slot on the top of the existing arc fault detector and lift the tab to release the locking clip. Rock the arc fault device forward and then out to remove it from the DIN rail. Once the 4 DC wires and the arc fault device has been disconnected, remove all of the components as they will not be reused. After the arc fault detector and wiring bundle has been removed, we can install the new arc fault detector. Remove the 4 DC wires from the arc fault device kit. If there is a cable tie bundling the wires together, it is not necessary to remove the cable tie now. Attach the yellow ferrule ends of the wires to the bottom of the DC disconnect switch. The wires must be terminated in the following order from left to right: blue labeled positive IN2, brown labeled negative IN2, red labeled positive IN1, and then black, labeled -IN1. These wires should land in the following numbered terminals from left to right: blue into position 8, brown into position 6, red into position 4, and black into position 2. Torque the terminal screws to 12 inch-pounds or 1.36 Newton-meters. Next, take the new arc fault detector from the kit and hold it in place while you pass the blue wire from right to left through hole 1 and pass the red wire from right to left through hole 2. Double check that both positive conductors are passing through the two different holes from right to left. Please take your time to ensure the next steps are performed properly. Start with the loose end of the brown wire and pass it through the same hole as the blue wire, but from left to right. This should be threaded through hole 1 in the opposite direction of the blue wire. Now, with the loose end of the black wire, pass it through the same hole as the red wire, and also from left to right. This should be threaded through hole 2 in the opposite direction of the red wire. Once the conductors have been installed through the arc fault detector, the positive and negative conductors of each input should be running in opposite directions from each other. Use a flathead screwdriver to lift the tab on the top of the arc fault detector and reinstall it on the DIN rail by catching the bottom of the DIN rail and rocking the detector inward. Adjust the wires through the arc fault detector. The black and brown wires should have a small loop but not tight. There should not be excess wire through the loops. Confirm the blue wire in particular is not pinched. Confirm the black wire is in the same hole as the red wire but in the opposite direction. Confirm the brown wire is in the same hole as the blue wire but in the opposite direction. Confirm that the loops in the negative wires wrap around the arc fault detector neatly. Be sure to maintain proper wire bending radius of the looped wire around the arc fault detector. Now, connect the other ends of the 4 DC wires to the correct locations on the DC terminal blocks. Route the wires neatly so they won't be damaged or tangled in any other field wiring. Terminate the 4 wires which go through the arc fault detector to the top side of the DC terminal block. Insert a flat blade screwdriver into the rectangular clamp release port. Insert the conductor in the round termination port above the screwdriver. Remove the screwdriver and perform a tug test on the conductor. Ensure the clamping terminal is making full contact with the conductor, and it is not clamping on the insulation of the conductor. Next, reconnect the black communication wire to the top of the arc fault detector. If desired, add cable ties to hold the wires together, taking care not to pinch or squeeze the insulation of the conductors. After all of the wires have been successfully terminated correctly, replace the front covers of the inverter box and switch box. Torque the cover screws to 13.2 inch-pounds. Once the inverter covers have been replaced, the inverter can be re-energized. The last step in this procedure is to apply the provided ECO C42212 label to the inverter chassis below the product label. Congratulations! The arc fault detector replacement has been completed successfully. This was a short video on how to replace the arc fault detector. If you have any additional questions, please call our technical support line and we will be happy to assist you.